ours.
Hi, here we go. Answers for 7A are these. These are the facts and they are undisputable. Number 1 should be 8. 1 should be 8. Number 2 is 80 yards. 2 is 80 yards. 3 is 0.13 seconds, 13 hundredths of a second. 0.13. 4 is $20.47. $20.47. Number 5 asked you for the sample space for the spinner if you spun it twice, correct? Oh, I don't have the test in front of me. It should be these. AA, AB, AC, BA, BB, BC, CA, CB, CC. Those are the different possibilities you can get when you spin that spinner. That's the sample space. We struggled with that before, so I'm wondering. Number 6 should be 5/9. 5/9. 7 is B. 7 is B. 8 is 108 million kilometers. That is 108 with 6 zeros after it. 108 million. 9, 7 and 1/2 inches. 7 and 1/2 inches. 10 is 3 3/8 inches squared. 3 3/8 inches squared. Number 11 is 0.1 repeater 6. 0.1 repeater 6 as a decimal, and as a percent it is 16 2/3. 16 2/3%. Number 12, I believe it asks you to prime factorize all that stuff, which means you get, oh boy, 5 2's on top, times 3 times 3. And then on the bottom, it's 2 times 2 times 2 times 3 times 3 times 5. Top again was 2 times 2 times 2 times 2 times 2, 5 of them, times 3 times 3. And then on the bottom is 2 times 2 times 2 times 3 times 3 times 5. When all of the smoke clears and you cross everything off that can be crossed off, you end up with 4/5. 4/5. 13 is side DA. Side DA or AD, I suppose. 14 is 7. 14 is 7. 15 is -18. -18. 15 is -18. 16 is 3. Ladies and gentlemen, 16 is 3. 17, you can either have 25 over 24 as an improper fraction or 1 and 1/24 as a mixed number. 25 over 24 or 1 and 1/24. 18 is 37. 18 is 37. 19 is 26. 19 is 26. And number 20, ladies and gentlemen, the grand finale is x to the 5th power. X to the 5th power. X to the 5th power. These are the answers. I cannot change them. Joseph?
Number 8, is it about the 0.13?
For which one?
For number 3.
What did I say?
You said 0.13.
Yeah, you can always put a 0. Joseph, you could have put 6 zeros in front of the decimal, so I'm going to change the answer.
What was number 6?
Number 6 was 5/9. Sophia.
How do I do number 2?
Let's do answers. If you have question number, answer first. That way everybody's kind of all on the same page. Aaron Murray.
118.
Number 18 was 37. Emma?
9.
Number 9 is 7 1/2. Zachary?
14.
14 is 7. Madison?
What was 8?
8 is 108 with 6 more zeros. 108 million. Zachary?
Was there a line coming in the paper that it was on?
Absolutely. Use your reference sheet, that's fine. And again, please, you can bring a piece of note paper if you want to jot down notes for yourself from this little review, which we'll go over. Who knows, maybe there are no questions, maybe you got them all right. Maybe everything was perfect in your world. Chase, what do you think? Perfect? Not quite? Close?
No.
All right, somebody asked me a question over there. So for what?
I'll write number 2.
Number 2. Ladies and gentlemen, number 2. Number 2. The ratio of the length to the width of a rectangle of the field is 3 to 2. If the field is 120 yards long, how wide is the field? Right, so basically you've got this. A couple different ways you can think about this. Up to you what you want. You could draw like the small little rectangle, and you know it is 3 to 2 here, right? And it is going to be proportional to the actual thing. The field is 120 yards long, so that's right here. So you could say, well, since it's proportional, I have the same scale factor. 3 times what is 120? Well, times 40. So I multiply this times 40. Most likely, though, if you did it the way I would talk to you, is we make a ratio box. Where you've got the small field, or the small, well, what do you do? It's just probably the small one to the big one. Your ratio is, you're comparing the length to the width. The length of the small one is 3, and you can kind of flip these around in whatever order you want. The width of the small one is 2. The big one's length is 120. And the small one you don't know, but it's still 3 times 40, and 2 times 40 is 80. Either one of those ways would be splendiferous. Hunter.
Are you doing number 20?
Number 20. Again, there's multiple ways to think about this one, but probably the easiest way, Connor, is what does x to the 3rd power mean? Times themselves, right? So I have on top 3 x's times themselves, and then another 5 x's times themselves. Kind of breaking it down all the way here. On the bottom, I have 1x and another 2 x's times themselves. Correct? 1 here, 2 there, that's 3. And these will cross cancel 1 for 1. And what are you left with? How many x's here? 5 of them. You could do it like this as well. Here's 1x. It's going to cross off with 1 of the 3 here to leave you with 2 of them. 2 of these x's are actually going to cross off with those 2, so you're left with that x to the 5th. In case you want to see it big. Oh, wait. Really big. Is that clear to anybody? Brian, does that look clear back there? Wait, it's not even close.
It hurts my eyes.
Hurts my eyes. This is nuts. Let's see if it gets clear as it gets smaller. Emma.
Was number 15 and 16 do you change their symbols?
Number 15 and 16. Alright. Here again is where the book kind of throws you for a loop. Remember, it's all about, well, we're all about adding things, right? You don't change anything unless it's subtraction. Subtraction, you're going to change it. This just means you have 6 negatives. This means you have 12 negatives. Altogether, you're going to have 18 negatives. Here, yes, to subtract integers, we add the opposite. So this actually becomes a +9. So you have 6 negatives, and you have 9 positives that you put in with it. Which means 6 of those will cross off with 6 of these, and you're left with 3 positive signs left over. Is that helpful with it? It's only subtraction that you think about changing those signs. Only subtraction. Zachary.
What was the answer for number 6?
Number 6 is 5/9 Caleb Fisher. Oh, so you had a question on 6?
Yeah.
This isn't a reference sheet, is it?
So 6 is
Oh, yeah, well, let's talk about 5 first, because you have to be able to do 5 to get 6 right. We had trouble with sample space, ladies and gentlemen. And sample space is all the combinations that you can possibly get. You are spinning this thing twice. And usually, it's a set of things, so we usually use my favorite little symbol in math to draw, which is that brace, to show it. If you spin this thing twice, how many combinations can you get? Well, you can get an A first and then an A second. You can get an A first and a B second. You can get an A first and a C second. Then you can get all the B's first. B first, A second, B first, B second, B first, C second. Then you get all the C's. You can get a C first and an A second, a C and then a B, and then a C, a C and a C. Those are all of your combinations. You can't get any other combination than those 9. And if you don't get that, you're not going to get this right, because this goes on to say, if you spin it twice, which is what we did up there, what's the probability that it will spin or you'll get an A at least once? So you find all of these that have at least one A in them. Let's take a look here. This has one A, that has an A, that has an A, that has an A, and that has an A. Those don't have at least one A in them, so you have 5 of the 9 spins. You get at least one A. So it's a 5/9 probability. Joseph, why are you looking? What's confused you on that?
Oh, never mind. I was counting the eggs, so I got 6 over 9.
No, that's you count each one as one spin.
Yeah.
There are 9 separate spins there, and 5 of them you'll get at least one A.
Yeah.
Great.
How many can we do?
Number 4. Probably my favorite problem on the test. If I knew what it was, that'd make it even better. Oh, these are my favorites. They are really good. At $2.20, actually this is relatively close to what I get. Believe it or not, this test was probably written. Oh, good night. Somebody wants to know. How old are these tests? No? Take a guess. Yeah, let me look and see. Copyright, 2007. 11 years ago, ladies and gentlemen, this was the price they put for gas, which is very close to what it is right now. Anyways, neither here nor there. If it was only $2 a gallon and you bought 9 gallons, how much would you get, Grace? How much would it be, huh? So you know it's just multiplication here, right? The problem with this is we got a lot of digits here, but you got to multiply the exact numbers, and then in the end you figure out what it rounds to as far as dollars and cents. So you're going to have to do $2.24, which is real because on the pump you actually do get charged that 9/10 of 1 cent. And you multiply that times 9.1. Did you happen to do that, Grace?
Yeah.
It didn't say to estimate. If you were to estimate, then you could have made this 10 gallons and that $2 or whatever, but you actually have to figure this out. Fortunately, the book is nice and they give you a 1 to multiply by. Most of us can probably do that, huh? Put a 0 down, 81, what's that, 36, 44, 18 and 4 is 22, 18 and 2 is 20. Hopefully I did my math right. You would stop me before I got too far off, wouldn't you? Now, obviously, the cost is not going to be $204,000 for this, so we got to put a decimal in there somewhere. Where would the decimal go? And how do I know, Madison?
You move it 4 spaces. So
4
it would
spaces.
be
Why?
after
Because there's
the
1,
0.
2, 3, 4 places here. 1, 2, 3, 4. So we get 20.4659, which would be $20 and 4,659, what, 10,000ths of the next dollar. You don't have that coin. The smallest coin we have is this place right here, which is our penny, right? So the choice is this, and here's where you have to be careful, okay? Our choice is either $20.46 or $20.47. And because this number next to the cent is 5 or bigger, you have to add 1 to that. So you would have to pay at the pump $20.47, which should make you a little upset because you actually paid 1,000. You actually paid what? No, 4,000ths of a cent more than you should have. Correct? If you were wise people, you would, when you get to buy gas and have to fill up your own car, you should calculate beforehand how many exact gallons you could put in, because if this number would have ended up being a 4, you actually would have got an extra 4 thousandths of a cent of gas when you pump that car. And so if you do that, 1,000 times, that'd be 4 cents. You could save yourself 4 cents. Oh, wait, no, maybe it's 40 cents. If I save,
Let's go with 40 cents.
if I save 4 thousandths, no, I save 4 thousandths of a dollar. Sorry, not 4 thousandths of a cent.
Oh.
You save 4/10 of a cent. So if you did it 10 times, you'd make 4 cents. If you did it 100 times, you'd make 40 cents. If you got gas 1,000 times, you'd have $4 to your name. You know what you could buy? Have a cup of coffee at Starbucks for $4.
Yay.
It's terrible coffee. Sorry, Starbucks. Did that help? Who asked the question? Grace, did you actually get this number?
No.
Did you multiply wrong?
Yeah.
Which is fine, but I think everybody probably needs to go over that. Joseph, question on this one? No.
How do you do number 9?
Me and number 9. Is this number 9 or is this the wrong one?
It's on the next page.
It is on the next page. I was hoping it would. Well, Joseph, the first thing I would think about is how do you get perimeter?
Side plus side plus side plus side.
And did you side plus side plus side plus side? Sir?
I did, but I didn't follow order.
No, it doesn't matter the order you do it, as long as you do it each. Matter of fact, logically, what would be the best way if you're adding all these sides together? Which two would you add first? Yeah, I'd put these two together first because 1 1/2 and 1 1/2 is 3. This would have been a quarter. And then maybe you want to do, what's this? 2 1/4 plus 2 1/4 is 4 1/2. So then you could add it together, 7 1/2. You can add in any order you want to make your life easier. Is that the right answer? Whether that is inches or however it goes. And then area is just multiplying. Make sure if you're finding multiplying fractions, you have to change them to improper fractions before you multiply. Please tell me you know better than to do this. You cannot take 2 1/4 and multiply it by 1 1/2 and just say, oh, 1 times 2 is 2 and 1/4 times that is 1/8. That is not going to get you the right answer. Improper, improper. 9/4 times 3/2. 27 over 8. Am I doing this right? 3 3/8. Note to self if you did that, please. Layton, did you have a question? I'm sorry, I wasn't in the good.
No, it was
Where else we at here? Madison?
Number 12, I don't understand.
Oh, heavens, the purgatory. Well, can I ask you, did you do division by primes? Did you do factor trees?
For 360, I did factor tree.
So you did the tree. Well, let's do that. Just make sure you got it. 360 divided into
10 and 36.
36 times 10, and?
Off of 36, it was 6 and 6.
Mm-hmm.
And off of 1 of the 6, it was 3 and 2.
Well, it should be both sixes, but
3 and 2.
3 times 2 and 3 times 2. Sometimes I like to circle these when I get to the end so I know that again. And then 10 is?
5 and 2.
So you have 2 3s, 3 2s, and a 5. So you have, what did I say? 2 2s, 3 2s, 2 3s, and a 5.
Yeah.
Perfect. And then on top you did what? How'd you split up 288, man?
I did division.
Okay, well, let's do that.
I divided it by 2.
And that's 144?
Yep.
And?
2.
And that's?
72.
And?
2.
That's?
36.
And?
2.
That's?
18.
And?
Divided by 2, 9.
Now I lost them.
9.
And?
3.
Did you put both 3s down?
No. Oh, no. I divided it by 3. Got
6? And then you do 6, you get the same thing no matter how you do it.
I put a 2 on top.
Instead of a 3?
Yeah, and I also put 360 the factorization on top. I know how to get it done.
I'm here for you, man. Connor.
So from no, when I did times 3, I just did it like times 2, like 180 times 2. Like,
Back, say again.
or like 180 times 2, and then I like kept on doing that. And then like, why can't you do that? Because,
Did you get the right answer?
no.
Okay, then that's probably a good idea why I shouldn't do that. You're telling me you did this. Did you just go in your head and say, okay, half through 2 is 180,
Well,
and
no,
then
I
2 is
actually,
90, and then 2 is 45, and then 3 is 5 times that 45 and 15, and then 3 and 5. Is that? Are you saying you tried to do a lot of it in your head, or what you told me you tried
no,
to do?
I wrote it down, but like, I did it like times 2.
Well, that's what this is.
Yeah, I know, but like on the bottom, probably 360 is like 5 times, I don't know, like, bunch of different things. Like,
Wait, if I wrote it down here, could you walk me through what you did?
Yeah.
Here, so here, let's look. 360. You said what?
180 times 2.
Did you break this? And did you type like this? Sure.
Yeah, as an extra code, and then I did 90, then I put a branch around, and maybe I put 90 times 2,
2 times 90, and then you circle the 2.
then 35 times 2.
Well, 90 of which is 45 times 2. 2 times 45.
I think that's right.
I would say that's probably a good observation, yeah. You can do it. You can do either primes or trees, it doesn't matter. Trees or factor trees or division by primes or I'm in the prime of my life, things, it doesn't matter. Fisher?
Problem 19.
I thought we did 19. Oh, yes, we did. Okay, let's get rid of this. Where do you think we went wrong, sir?
I really don't know.
Order of operations say you should do what first, sir?
Parentheses.
So you got what?
2.
So I still have my 5 squared minus 3 in parentheses times 2 plus the square root of 49. Then,
Exponents.
and you got
25.
25 minus 3 times 2 plus square root of 49,
7.
7. Then,
Multiplication.
which gave you 25 minus
6.
plus 7. Now, did you get this part far?
Yeah.
Now, did you go minus 6 plus 7 was a plus 1, so that plus 25 is, I don't know, what did you do from here?
I added 6 plus 7 and then subtracted that.
Yeah. Caleb Fisher has brought up a very good point that you need to be very aware of. Why can't you do that? Why can't you do 6 plus 7 is 13 and then subtract that from 25? Because, Zach?
Because if you look at the order of operation, you have to look from left to right.
Because these addition subtraction fall on the same level of order of operation, you have to work your way from the left side to the right side. You have to go 25 minus 6 first, and get 19, and then 19 plus 7 is 26. Okay. If it was just addition, Caleb, if those were both addition signs, it wouldn't matter because there's that whole commutative property which seems to. But with subtraction, you can't do that. Subtraction, you have to go from left to right. Otherwise, what will happen to everybody will happen to you, or whatever happened to you will happen to everybody. You have to go left to right. Closing, any questions? I don't think so. Zachary?
What was number 9?
The answer? The answer to number 9,
8.
7.5. 8 was 108 with 6 zeros, 108 million. Madison.
For the test, on number 11, then we use
Did somebody already ask me this question?
yes.
What was my answer?
Yes.
Okay.
Said you can use your reference sheets, that's fine. At some point, you'll get to know these fractions, but 1/6 is a tough one. It's not as common as 2/3, 3/4, or 16/35. Madison.
I don't understand. I really did not understand number 13.
Wait, do you really not understand, or do you just really not understand? Is it 2 reallys or just 1? Because I need to know this, the emphasis part. Alright, first thing you gotta do is break apart what they're telling you. Angle ABC. ABC and DAC are similar. Who cares, you ask?
Who
cares?
Well, we have to know because it's actually part of the problem. What, Madison, does it mean to be similar? I don't even know what the question asked, but I'm gonna break it apart right here.
They
Similar shapes have what?
similar size.
They have what type of angles? Similar shapes have what type of angles? Give me the mathematical wording of it, and I'll be the happiest person alive. Anybody know what that wording is?
Corresponding.
What do they have? What about their corresponding? What about their corresponding angles? Corresponding angles are, John? Equal. So you have to know, what are the corresponding angles here, Madison? Well, obviously this angle corresponds to this angle. Those are equal, right?
Yeah.
Angle B corresponds to what angle?
D.
Right, so these two are the same, and angle A is split in half, so this and this have to be the same. The other thing you know about similar shapes is their sides are not equal, but proportional. If it said they were congruent, then they'd be equal. And it just asks you this, what side on BAC corresponds to AB? So here's AB. What side on the other triangle, on this triangle here, Madison, would be the side that matches up to in length on this triangle over here? That's all they're asking.
Okay.
Well, obviously AC corresponds to AC. Okay, and then you can just go from longest to shortest. Okay, this is the shortest line, so these two are going to correspond, and these two are going to correspond. That help?
Yeah.
Now you really understand it now? Or
Yes.
really understand it? Just go one really. I don't think we want to go too far. So,
What made you number 10?
well, you already did number 10. Right here. I multiplied this times this, which is how you find area, and I went through the long spiel that said you can't just multiply the two whole numbers together into two fractions because you get a wrong answer. You have to change them to improper, and then multiply across. 9 times 3 is 27, 4 times 2 is 8, and that's what that is as the next number. Did I say that? I said that. Emma,
Number 14.
number 14, ladies and gentlemen. I knew it was up here somewhere. Solved by inspection simply means you could do this by multiplication or division. Emma, how do you go from 12 down to 4?
Divided by 3.
So 21 divided by 3 is 7. And that's what, there's no rhyme or reason. I mean, there's a reason, but inspection just means you should be able to kind of look at it and see. It should be kind of a mental sort of thing. Eventually we'll get to where we solve that inequation thing. Some of you look bored. Some of you. Maya, you should pick up doodling. Doodling can help you not fall asleep or whatever. Right, Sarah Grace? Other ones while we're here, let's not cut it short here. You know this will all be on film for you to review at a later time. So,
I understand that we already did number 21 under Pretest.
you want a review of the review of number 20?
Yeah.
Alright, oh, good, because I erased it. How about that? So what did you do? Let me ask you, how would you simplify that? Which gave you what? What'd you get when you multiplied those two? And that's what you should get. So on top you got x to the 8th power, correct?
Yeah.
And then on the bottom you got x to the what? How do you get 4? There's 2 there and only 1 there. Good. And if it doesn't have an exponent, it's a 1. So 1 plus 2, there's x to the 3rd on the bottom. And if you have 8 x's on top and 3 x's on bottom, 3 of those are going to cross off of 3 on top and only leave you with 5 of them. And you can feel free to draw the x's, but they just look like this. This has 3 of them, so boom, 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 you're left with those 5 x's. And it's not 5x, it's x to the 5th. We're not adding those together. Leighton, I knew there was a question in there, sir.
How do you do number 18?
Thank you, ladies and gentlemen. Well, Leighton, if I had to guess where you went wrong, anybody else want to guess with me? Let's make this a student participation. Because I think Leighton understands how to work all this stuff out. If you had to guess where Leighton went wrong, this would be my guess, and I could be way wrong or way off on this. I would say what, Autumn?
He took the decimal and left it.
That would be my guess. Leighton, what is 0.3 times 0.3? Thank you. I have some applause for that. Leighton, unfortunately, 3 times 3 is 9, but there are 2 decimal places there, which means the decimal comes back 2 places, and it really should be 0.09. Okay? And you should feel good about that, because I knew that's probably what you did wrong, because anybody else in here did it. I would say probably 3 or 4 people probably did that. People always think that when they see those easy numbers times themselves, they always try to kind of lose sight of what's going on. And then you'd have to take 4.6 and subtract 1.27, which would give you what, 353.3? Wow, a lot of 3s, is it? 3.33, right? And then maybe we went wrong with the division. You're dividing the bottom into the top. And you just have to remember that you need to move the decimal over 2 places, and it will go into here. Does 9 go into 333? You should right off the bat say yes or no. Does it, Lauren? How do I know? Oh, it shouldn't take you that long to answer. 4 words should give me the answer. Caleb?
Some of the digits.
Some of the digits, yeah. 3 plus 3 plus 3 is 9, so 9 goes into that. 9 goes into 33. What? 3 times that's 27. 9 goes into 62. Sum of the digits works for 3 and 9, nothing else. Uh-oh. Is it about this one, so? Did I do something wrong? Leighton, would you have gotten it right if your decimal was in the right place? Did you get 22 and a 7 somewhere? Like 270 or 2.7 or? So, I thought we did 17. Now, again, remember, this order of operations say what has to be done first? Huh? Left to right. So you just take 7/8 minus 1/2. What is half but 4/8? Did you get 3/8 for that, Sophia? And then you're adding 2/3 to that. Oh, do I have some room over here? Sure I do. 3/8 plus 2/3. What's my common denominator? So, I'll help you out with that. Stop me. Did you not get what I got something? Did you see where it all shook down or no? Can we go slower?
Yes.
Okay. Did we get to this point? You didn't get there. Did you get to where 3/8 came from? So, this was 3/8, right? So now I have 3/8 plus 2/3, correct?
Yeah.
3/8 plus 2/3. I have to find common denominators, which are.
11.
Oh, great! I might have to take my glasses off for this, though. Do you want some poses?
I'm just gonna do some game
Random
stuff. Maybe
shots.
working.
While we keep continuing.
Hiding the calculator in there.
Yeah, or you know, calculators. Joseph's had a rough day already. You might want to get a picture of him. Get a picture. That's the picture we need right there. Yes, the questionable picture there. He's pretty photogenic. Anyway, so did you catch this one right here? You know why it's 24, right? And then 3 times 8, 2 times 8, 8 times 3, 3 times 3. And then when you add those together, you get 9 plus 16. What's that? I think it's 25. And like I said, the book lets you keep it as an improper fraction, or you could change it to that next number. It really, as a seventh grader, it's your call. You should feel older and more responsible now. It's hard to do when somebody's taking your picture, isn't it? We're actually done, so. You can take it. Yeah.
Alright, you guys wanna do a quick team picture? Then I'll
But
get
I think we're close to being done.
2-minute break?
Yeah.
So I go that way? I've seen them, I've never seen them at work.
It's nice when you can put the test up there, I mean, you can kind of
Okay.
Oh, good luck getting this group to smile.
You gonna jump in?
Well, this really isn't my class.
Is that yours?
Oh, yeah. Joseph jumped in. Get in front somewhere. You gotta get in front at least. Back up a little. There you go. And Caleb and Layton, you guys are not even in the picture.
Hey, this how's it gonna work? We're gonna have 3 rows. Tall, stand, you guys are